Hello, Year 11. Today we are going to be starting a new topic. It's going to be a relatively short topic, but we are going to be looking at, during the course of these lessons, how we start finding the gradient of curves. We know how to do it for linear functions, but for a curved function, the gradient is constantly changing. So today we're going to have a little bit of a revision lesson, making sure we can find gradients of straight lines, because that is the key skill that is going to be required over the next few lessons. So I'm going to be reminding you the two different methods that we will have looked at for calculating the gradient of lines. Both of these methods we looked at in year 9, but very likely we met them again in year 10. So the gradient is a rate of change, and the reason why the gradient's a rate of change, if you think about it, what does the gradient of a line represent? Well, the steepness is how much the y rate is changing in relationship to the x rate. So it's a measure of how y values change in relation to x values. So that is a rate of change. Now, the first method that we will have used, and you'll have used this even in year 8 as well, is to draw the little triangle on your linear function and drop the perpendicular and the horizontal to form a right angled triangle, and use our formula, changing the y over changing the x, or difference in the y over difference in the x. And we'll have a go at using this method in a minute just as a refresher. There was then a more complicated method that we used, which in essence is actually doing exactly the same thing, where we use two coordinates and substitute the numbers into a formula. So although method 2 is more complicated, there was a couple of reasons why it was a better method. So if you've managed to print out this sheet, great. If not, just jot some of these things down. But one of the reasons method 2 was better is because straight away you don't need a diagram. So I'm going to write here, because you don't need a diagram. And there was a second reason why method 2 was better. And I don't know if you recall this, but when you use method 1, and you create the triangle and you work out the gradient, you then have to look back at your graph and decide, is it a positive gradient or is it a negative gradient? Well, method 2 does that for you. It gives you the answer either as a positive number or a negative number. So I'm just going to put another little extra part. It tells you if the gradient is positive or negative. So let's start with a couple of examples looking at what I would refer to as the easier method, the triangle method. So let's have a look at the gradient of the red line first. Now remember, it doesn't matter which points you pick on your line, but you wouldn't, when you're choosing coordinates, pick something like that because it's in the middle of nowhere. You need to always pick two coordinates that have exact values that you can read off your graph. So I think I'm going to use, to keep it nice and tidy, 3, 3 and 6, 4. So just at the side, I'll put red line. And I've chosen my 2 points. I drop my vertical. I put in my horizontal. This could be done with a ruler. And then I count that difference. So the difference in the y from 3 to 4 is 1. And the difference between 6 and 3 is 3. So my gradient for the red line is 1 divided by 3. So that would be left as a third. Of course, you could go on to find the equation of the straight line, I'm not really interested in that today, but we might as well just quickly do it. It'd be y equals a third of x, because remember the third is the gradient, and then you could read off your intercept, and it would be plus 2. So that's just a little bit extra. I've now just quickly done the equation of the line. Let's have a look at the other line, the purple line. So I'll do this in purple. Now you've already spotted, I imagine it's sloping the other way. You've already spotted it's quite a steep line, so we might be expecting a large gradient. What coordinates should we use? Well, there's not too much choice. I'm going to pick -2, 3, and I'm going to pick the one that's the intercept. So again, I'm going to draw in my triangle by drawing in a vertical and a horizontal. So counting my vertical, that appears to be 8. My horizontal difference in the x appears to be 2, and 8 divided by 2 is 4, but of course we have to manually write in that it is negative. If you are interested in the equation of the line, let's just do that whilst we're here. So since the gradient is -4, it would be -4x, and it crosses the y-axis at -5. So the equation of that line would be y equals -4x. Take away 5. So in my second example, there is a deliberate mistake. It says Joey thinks that the gradient of the red line is 4. Explain why he is wrong. Have a look. Can you see the mistake? So, where is the mistake? Well, this sometimes happens in graphs. It is sometimes that the scale on the axes isn't the same. So it's not just a case of counting the spaces. You really need to concentrate on actually looking at the difference and counting the numbers. So this is the mistake. You can see the change in the x. It might be 2 of these spaces, counting the kind of rectangles, but if you actually look along the scale, that number should be 4. So the gradient should be 8 divided by 4, which is 2. Again, if I wanted the equation of the whole line, it'd be y equals 2x and crosses the y-axis at 3. In the questions that I'm asking you to do today, there are no equation questions, but it is worth discussing whilst we're passing by. So let's have a go at a couple of the questions where we're using the formula. I'll just scribble the formula where I can see it because I might want to refer to it. So m equals y2 minus y1 over x2 minus x1. So this is just a job as substitution, but it's always really important to label your coordinates and not get them mixed up. It does not matter which one you call x1, y1 and which one you call x2, y2, but what does matter is you call one coordinate 1 and one coordinate 2. Don't mix up the 1s and the 2s, otherwise things will go wrong. So before I even start either of these questions, I'm just going to call this one x1, y1, x2, y2, and the same over here. x1, y1, x2, y2. So let's do the gradient of this one. It is y2 minus y1. So showing my working out, it is 15 minus 9 divided by x2, 7 minus 4. 15 take away 9 being 6, 7 take away 4 being 3, and 6 divided by 3 means the gradient of that line would be 2. Second one, we have got some negative numbers. We might need to be a little bit careful on this one. Let's go for it. y2, negative 27. We are going to be subtracting negative 3. So I'll have to be careful with that double sign in a moment. We've got x2, which is 3. And we are taking away negative 5. So again, I've got another double sign. So I hope you remember that when you subtract negatives, that's equivalent to adding. So we are going to end up with negative 27 plus 3 is negative 24. And 3 plus 5 is 8. And negative 24 divided by 8 is negative 3. So please have a look back at my instructions because I've provided a link to my PowerPoint that has these questions. There is also an extension question where you could do a little bit of work of Pythagoras and find the length between some line segments. As always, if you have any problems, do not hesitate to get in touch via the Ask the Teacher channel.